Hi everyone. In this video, we're going to be doing A Level Maths 9709, Paper 32, Pure Maths 3, October, November 2025. This paper is 1 hour 50 minutes long, so we'll try to finish within that time limit. So let's get started. Okay, so for the first question, we need to sketch the graph of y equals to modulus of x plus 3a, where a is a positive constant. Okay, so to sketch a modulus graph, we need to first find out our x and y intercepts for this graph. So let's find out what our x-intercept is. So to find that out, just substitute y equals to 0. Yeah, so then you get x plus 3a equals to 0. And you would get minus 3a for your answer, for your x-intercept. Okay? Yeah, so... And as for the y-intercept, same thing. Just substitute this time the x equals to 0. Then you would get y equals to 3a. So let's sketch it. So this is our y-axis and this is our x-axis. So we have established that our x-intercept is negative 3a. So I'm just going to place, so this is 0, this is a, this is 2a, this is negative 3a, negative 2a, negative a. So this is negative 3a, and this is a, 2a, and 3a. This is our y-intercept. So let's join these two lines up. Okay, I mean, that wasn't too good. Let's do it again. Let's join. Yeah. And um, and as you know, beyond this point, this graph would continue below this. However, since we obviously have the modulus sign, we have to bring the portion of the graph that is below the x-axis above the x-axis. So we basically have to reflect it up. So now it's going to be like this. Make sure that they look symmetrical. The gradient still has to be the same. Yeah, it looks symmetrical. Yeah. So yeah, I'm pretty satisfied with the sketch. So this would be our final answer for the first part. Let's head on to the second part. Okay, so now they told us hence or otherwise. So we can either use the answer from the previous part or do our own way. We are told to solve this inequality. So since we have the graph, let's use the graphical method. So we are like taking note of the keyword hence. So we're going to use the answer in the previous part. So to use that, I'm going to try to sketch the graph of a minus 2x on our axes. So I'm going to use a different color for this. Okay, so let's find the y-intercept. So y-intercept, substitute 0, we get a. So yeah, this is the y-intercept. And the x-intercept, just substitute a minus 2x equate to 0. And then x, you would get a over 2. Okay, so a over 2. So this is our a. So a over 2 would be somewhere here. Okay, yeah. So let's sketch it. Let me see. Okay. Yeah. Okay, doesn't look accurate enough. Since the gradient of the graph is -2, well, for our modulus, the gradient is just 1. Because the coefficient of the x's. Yeah, I'm gonna try to do it again. Okay, so this is A. Okay, let's set it to here. Okay, yeah, now it looks better. Yeah, this looks much more accurate. So this is our y equals to a minus 2x uh, graph. So as we can see from our um, sketch, there is only one point of intersection between these two graphs. So let's try to find that point of intersection first. So in order to find it, let's see which branch of the modulus graph the point of intersection is on. So you can see it's on the right branch of the modulus graph. And this is the part of the graph that, if you remember, we did not reflect it up. It was a part of the original graph without the modulus sign. So yeah, we don't. So we can just equate. Okay, let me change the color back to blue. Yeah, so we can just straight away equate our original equation, x plus 3a with a minus 2x. So let's solve it. So bring the 2x to the other side. So you get 3x and minus 3a from both sides. You get minus 3a plus a. So that's minus 2a. And then you would get x is equals to minus 2 over 3a. So yeah, according to a sketch, yep, it supports our sketch. So that's the um, x value of the point of intersection. So now we are ready to solve this inequality. So this inequality tells us to find the values of x for which the modulus graph is more than our a minus 2x. So we can see in our graph that would be to the right hand side of our intersection point. So hence, our final answer would just be x is more than -2 over 3a. Yeah, so, okay, let me see if there's other values of x where, mm, so, yeah, nope. Yeah, the left branch will always be smaller than y equals to a minus 2x. Yeah, so we don't have to include that. So yeah, this would be our final answer for this part as well as the entire question. Let's head on to the next question. Okay, so for the second question, we are told to solve this equation, and we need to give our answer correct to 3SF. Okay, so looking at this equation, this is your typical exponential equation. Yeah, where you have to use your logarithms in order to solve for your x. So let's copy down our equation. So I'm just removing all the multiplication sign and replacing them with brackets. Oh, sorry. Okay, so we're done with that. Now let's split up the 2 to the power of x plus 1. So we can rewrite this as just 2 to the power of x times 2 to the power of 1, or just times 2. Oh my goodness. I'm sorry. Uh, okay, and let's do the same for this other expression, 3 to the power of 2x minus 3. So you would get 3 to the power of 2x times 3 to the power of negative 3. Sorry everyone for the delay. So as I was saying, we split these up, okay? And then we multiply all the numbers together. So in this side, we got 3 times 2, which is just 6 times 2 to the power of x. And then for this, we have 4 times 3 to the power of negative 3, which we can rewrite as 4 over 3 to the power of negative 3, which is also the same as 4 over 27 times 3 to the power of 2x. Okay, now let's move all the x terms to one side and all the constants to the other. Okay, so let's do that. So I'm going to move the 3 to of 2x to that side. So 2x divided by 3 to the power of 2x divided by equals to 4 over 27. And I'll move this 6 to the other side. So just divide by 6, multiply by 1 over 6. Okay, so now for the left-hand side, I'm going to re-express the 3 over 2x as 2 over x over 9 to the power of x. Okay, and then this one simplifying 3, 3, and then this becomes 2. Yeah, so then this becomes 2 over 81. Okay, so now for the left-hand side, since both the numerator and the denominator, the powers are the same, we can combine the powers together and just keep the 2 over 9. So basically, yeah, so this is what we do. Goes to 2 for 81. Okay, now we can take ln on both sides, or any log base. Just gonna take ln. And then for this, using a product rule, we can bring down the power. So now we have x times ln 2 over 9 equals to ln 2 over 81. Now just divide both sides by ln 2 over 9 to get x on its own. So for this, just press your calculator. So ln 2 over 81 divided by ln 2 over 9. So you would get 2.46 to 3SF. So yeah, this is a final answer for this question. And if you want to be sure whether the answer is correct, type the exact answer in your calculator and substitute it into both sides of the equation. If the answers match, yeah, you're good to go. So with that, let's head on to the next question. Okay, so for this third question, we are given an Argand diagram and the shaded region. So the shaded region, the Argand diagram, yes, bounded by a line and a circle, and it represents the complex numbers satisfying these. Sorry, satisfying these. Sorry. Okay, so as I was saying, the inequalities are real part of z less than 2 and the modulus of z minus bracket 3 plus I less than 2. And it also says the point P shown on the diagram is one of the points of intersection of the line and the circle. So this or this can be point P. Oh, never mind. They already labeled it for us. Okay, so for the first part, we are told to find the complex number represented by point P. And we have to give our answers in the form x plus I, where x and y are real and exact. Okay, so from the diagram, we can clearly see that point P is just the lower intersection point of the circle and the line. So now the only thing remaining to do is to find the Cartesian equations of the line and the circle. So for the line, very simple. So this line is actually the boundary of this real part of z less than or equals to 2. Yeah, so this line cuts through the point on the x-axis too. So this line would just be x equals to 2. And as for the circle, this inequality is what represents the circle. So to understand this inequality, we need to know that the real part of the complex number inside the modulus, that's the x coordinate of the center of the circle, and the coefficient of the imaginary part, that is the y coordinate of the center, and the number after the inequality sign. So this number right here, that's the radius. So using these key pieces of information, we can form the Cartesian equation of the circle. So you should know from your AS. So it's just x minus the x coordinate of this center, which in this case is 3, plus y, and then subtracted with the y coordinate of the center, which is just 1. That's the coefficient of I. So y minus 1. Oh, sorry. You have to put the square. Don't forget. And this all equals to the radius squared. So the radius is 2 in here. So this is just going to be 2 squared, which is 4. So this is equation 1. And the line, that's just x equals to 2. This is equation 2. So to do that, just substitute equation 2 into 1. So you would get 2 minus 3 squared plus y minus 1 squared equals to 4. Now isolate your y minus 1 squared. You would get 2 minus 3 squared, that is 1. Then 4 minus 1, that is 3. So taking the square root on both sides, you'll get y minus 1 is equal to plus or minus square root 3. And hence, for y, we would get 2 answers. First, let's take the positive square root. So first you'll get positive square root 3 plus 1. And the second one, you would get negative square root 3 plus 1. So now let's see which one point P is. So on the diagram, point P is the lower point of intersection. So obviously you can see the y coordinate is lesser for point P. So yeah, the obvious choice would be this as the y coordinate of point P. So that's rejected. However, we don't want the coordinates of point P. They want us to write down the complex number that point P represents. So in the form x plus iy, x would just be the x coordinate of point P and y would just be the y coordinate. So hence, our final answer would just be 2 plus I times 1 minus negative 1 minus square root 3. So yeah, this would be our final answer for the first part of this question. Let's head on to the next part. Okay, so now for this second part, we're told to find the greatest value of argand z for points in the shaded region. So the greatest value of argand z, if the, so, okay, argand z is basically the angle that any point in the argand diagram, so let's say this point, we call it Z, the angle that the line connecting the complex number to the origin, that line, whatever angle that line makes with the horizontal real axis, that is called the argument. So it's represented by argand Z. Now, the greatest value of argand Z, uh, if okay, if it is, how do I say this? If the entire circle or the entire region is below the real axis, so everything is, the y coordinate is negative, or the imaginary part is negative, the greatest value would mean the lowest angle. Yeah, the lowest angle if everything is below the x-axis. But in this case, we have one part below the real axis and one part above it. So for greatest, yeah, we can just stick with the biggest angle, but that's only if it's above the x-axis, above the real axis. If it is not, then that would be the lowest value. If like we're talking about the greatest angle below the real axis. So I know it's confusing. So to summarize, it's basically just the magnitude of the angle in radians, like including the sine. Okay, you don't exclude the sine. Yeah, so let's get to finding it. So to find the greatest value of argand z, uh, you can take a ruler and then pivot it at the origin and just slide your ruler across the whole shaded region until you come across the greatest angle. And if you do, your ruler would line up across this blue line that I marked here. Yeah, and hence the greatest uh, value of argand z would be this angle. Okay, so to find this angle, one thing we can take note of the line that we sketched here is that it's tangent to the circle that they gave us in here. And one property that you must know of any tangents to a circle is that the line connecting the point on the circle, which the tangent passes through, to the center of the circle is always perpendicular. So it's always 90 degrees. Okay. Yeah. So okay, let's see what else can we make use of. Mm, okay, so all right. And now let's make a right angle triangle using the center of the circle. So this would be the hypotenuse. This would be the right angle. So you can see that the argand is actually the sum of these two angles that we have to find separately. So let's find this angle first. We're going to call this theta. So to find theta, we just have to know the coordinates of this. So this is basically just the center of the circle, which we already given here, 3 plus I. So hence the coordinates would just be 3, comma 1. Yeah, 3, comma 1. So we can immediately know the angle of this. like the length of this side, which is just 1, and then this side is 3. Okay, so you could just use your basic trigo. You would get tangent theta equals to opposite. So opposite side is 1 over the adjacent side, which is 3. Okay, so this is tangent theta. So theta is just tangent inverse 1/3. Now let's find the second angle that makes up. We're going to call it alpha. So to find alpha, let's look at the sides of the right angle triangle that we know. So first, it would be this side, which is basically just the radius of the circle. So we know the radius of the circle, obviously, is just 2 from the previous part. And this side as well. So this side is actually the hypotenuse for both of the right angle triangles we made. And since we know the other two sides of this right angle triangle, we can just use Pythagoras and quickly figure it out. So 1 square plus 3 square, you will get 10. So this would just be square root 10. And then you just use your simple trigo, you would get so opposite over hypotenuse. So this is sine alpha equals to opposite, which is 2 over the hypotenuse, which is just 1 square plus 3 square. So hence alpha would be sine inverse 2 over square root 10. Yeah. Um, yeah, so it would just be that. Yeah, let's just leave it as that. Okay, so hence argin Z would just be theta plus alpha, tangent inverse 1/3 plus sine inverse 2 over square root 10. Yeah, so this, you can do it in either degrees or radians, up to you. Yeah, so you would get 1.01 radians to 3SF if you got in radians. For degrees, it should be 57.7 degrees to 1 decimal place. Yeah, so this would be a final answer for this part as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told to find the exact value of this particular definite integral. Okay, so first things first, we realize that this integral is actually a product of two functions, x and tangent inverse x. So whenever we have a function like this that we have to integrate, we should automatically think of integration by parts. So let's copy down the integral. Now the formula for integration by parts is given, yeah, right here in your MF19. So this is the formula that you need to use. So you can see on the left-hand side, there's two parts to this equation, u and dv dx. So we have to set which function would be u and which one would be dv dx. And this would be equal to u times v minus the integral of v times du dx. So in short, we need to know u, du dx, dv dx, and v. Okay, so yeah. So in order to figure out which one should be our u, which one should be our dv dx, to choose u, there's actually a rule that we can use called liate. So liate stands for log. So log or ln, and then I is for inverse functions. So in our syllabus, we only have tangent inverse, and then A for algebraic, so your polynomial in terms of x, so x squared, x cubed, whatever. And then T is for trig functions, and then E is for exponential functions. So your e to the power of whatever x. Yeah. So first things, we should take the functions we have in our integration by parts. So we have tangent inverse x, which is the inverse, and we have x, which is algebraic. And whichever one comes first, we choose this to be our u. So we have to choose the inverse function to be our u. So tangent inverse x must be u. And with practice, you don't have to do this whole thing to figure out what you should let your u be. You would get it automatically. So yeah, this is u, and hence our dv dx consequently is just x. So let's find out du dx. So to differentiate tangent inverse x, it's given in our MF19. So under differentiation, you have tangent inverse x as fx, f prime x. Oh, it's sorry, here, tangent inverse x under fx, f prime x, you get 1 over 1 plus x squared. So this would just be 1 over 1 plus x squared. Okay, and then for v, just integrate your x with respect to x, you'll get x squared over 2. All right, so now we're ready to integrate. So the integral of x times tangent inverse x dx is equals to u times v. So u times v, that is x squared over 2 times tangent inverse x. And since it's a definite integral, don't forget to include your limits on the right-hand side. And then this would be minus the integral of v times du dx. So v is x squared over 2, and du dx, that is 1 over 1 plus x squared dx. And again, don't forget to include your limits. So let's evaluate this part first. So substitute 1, you would get 1 squared over 2, so just half tangent inverse 1 minus 0 squared over 2, so you just get 0 times tangent inverse. So that's just 0, so you just get half, and then tangent inverse 1, and then minus. For this one, we have a scalar inside, so you can take that out. So minus half integral of x squared over 1 plus x squared dx. So this one, tangent inverse 1 is just pi over 4, and pi over 4 times half, that is pi over 8, and minus half. And to integrate this function, you can do your long division. Okay, let's just put it here. Let's just leave it like this for now. Okay, so let's re-express this function. So to do that, we are going to use our long division. So we're going to divide x divided by 1 plus x squared. So x squared plus 0x plus 0, we divide it by x squared plus 0x plus 1. So subtracted. Yeah, so the coefficient is the same. You have to multiply anything. So this should just be 1. So x squared plus 0x plus 1. The remainder you would get as negative 1. So hence, x squared over 1 plus x squared, you can re-express it as the quotient, which is 1, plus minus 1 as the numerator over 1 plus x squared. So the denominator remains the same. And we can rewrite this as 1 minus 1 over 1 plus x squared. Okay, so let's bring back this expression and replace it with 1 minus 1 over 1 plus x squared dx. Okay, so now this is a lot easier to integrate. We don't have much space. So integrating 1 is just x. And this one, if you remember, that's just the derivative of tangent inverse x. So this is just tangent inverse x. And yeah, don't forget to put your limits. So pi over 8 minus half times. So 1, you got 1 minus tangent inverse 1 minus 0. So bracket 0 minus tangent inverse 0. That's also 0. So this whole thing is just 0. So pi over 8 minus half times 1 minus tangent inverse 1 pi over 4. Yeah, minus 0 minus 0. Yeah. So expanding everything, you will get pi over 8 minus half plus pi over 8. And your final answer would be pi over 4 minus half. Yeah, so this would be our final answer for this question. And if you want to see whether you got it correct, just type the exact integral into the calculator. If your calculator supports that, and see if you get pi over 4 minus half, like the non-exact answer. Okay, so yeah, with that, let's head on to the next question. Okay, so for this question, we are told that fx is equals to x minus a squared times gx, where fx and gx are polynomials. And we have to show that in this case, x minus a is a factor of f prime x. Okay, so let's first start by evaluating f prime x. So f prime x would just be the derivative of x minus a squared times gx. So we're differentiating a product of two functions. So automatically you should think, oh, I'm gonna need to apply the product rule. So that's what we're gonna do here. So to apply it, you keep the first term and differentiate the second term. And then you add the plus sign. Now you keep the second term and you multiply it by the derivative of the first term. So for this one, this would just be, you bring down the power, so 2 times x minus a, and then you minus 1 from the power, so 2 times x minus a to the power of 1, and then you multiply it with the derivative of the inner function, which in this case x minus a, so the derivative is just 1, so multiply by that. So you would get x minus a squared g prime x plus 2x minus a gx. And to prove whether this is a factor of x minus a, let's just try to factorize x minus a. So as you can see in this case, it's possible. So factoring out x minus a, you would get x minus a times x minus a g prime x plus 2gx. So getting this result, you can say hence x minus a is a factor of f prime x shown. So this would be the final answer for the first part. Let's head on to the second part. Yeah, so the second part, it says that x minus 3 squared is a factor of this polynomial But P and Q are constants, and we need to find the values of P and Q. So first things first, if we are told that a certain expression is a factor of this, um, what we can do is we can take the factor and then we can equate it to 0 and then solve for x. So this one, very straightforward. You'll just get x equals to 3. And now you're going to substitute this x equals to 3 into the polynomial. I'm just going to write down the whole thing. Plus px plus q. Yeah, so you substitute this and you equate it to 0 because that's what your factor theorem says. So like x minus a is a factor. You substitute a into the polynomial, it has to be equal to 0. And if there's a remainder, then it equals to the remainder. That's the remainder theorem. Okay, so anyway, let's do that. So 2 times 3 cubed minus 4 times 3 squared plus 3p plus q is equals to 0. So just press your calculator. 2 times 3 cubed minus 4 times 3 squared, you get 18. So you get 3 plus p equals to minus 18. So this is our first equation. And obviously we did a second equation to find the value of p and q. So now the question is, how do we do that? Well, if you see the case that they gave us in here, x minus 3 squared, it's almost very similar to the general case that they gave us in the first part. So yeah, so our fx is this. So fx is x minus 3 squared times arbitrary polynomial gx. It's also the same case here. So here we can say that x minus 3 is a factor of the derivative of this polynomial. Yeah, so we're using the result of the first part in our second part. So let's differentiate the polynomial. So you would get 3 times 2x squared minus 4 times 2x plus p. Yeah. So this is our differentiated polynomial. And since x minus 3 is a factor, okay, let's simplify it first. 8x plus p. And now you sub x equals to 3. You would get 6 times 3 squared minus 8 times 3 plus p equated to 0. Yeah, so then you would get 6 times 9 minus 8 times 3, 30. So you get p plus 30 equals to 0. Then you would get p is equals to negative 30. So we found the value of p. Now let's find the value of q. So 3 times negative 30 plus q equals to negative 18. Then you would get q is minus 18 minus negative 90. So this is 72, if I'm not wrong. So 19 minus 18. Yeah, that's 72. So these are our values for P and Q. And yeah, we have come to the end of this question. So let's head on to the next question. Okay, so for this question, for the first part, we are told by sketching a suitable pair of graphs. Sorry. Okay, so as I was saying, we need to sketch a suitable pair of graphs we need to show that this equation, cotangent 2x equals to 2 sine 2x plus 1, minus 1, has exactly one root in the interval of x between 0 and half pi. Okay, so to figure out what graphs you have to draw, just look at both sides of the equation. Yeah, so you just have to draw y equals to cotangent 2x, and the right hand side, y equals to 2 sine 2x minus 1. So let's draw our axes. So this is the y, and this is the x. So x, it goes from 0 to pi over 2, and the midpoint would be pi over 4. Okay, never mind. You can do a bit better for the midpoint. So the midpoint, it's, sorry. Yeah, I think the center can be there. Yeah. So this is pi over 4, the midpoint. Yeah, so let's start by sketching y equals to 2 sine 2x minus 1. So there are two ways which we can do this. So one way is to just substitute the key values of x into the equation, and then you can get your y value. So let's do that. For that, so 2 times sine 0 minus 1, you'll get -1. So I'm going to put -1 here. So this is the first point. And if we do it for 2 times sine 2 times pi over 4, sorry, minus 1, we would get 1. So 1 is just here. Yeah, so 1 is here. And then let's do it for pi over 2. So 2 times sine 2 pi over 2. So you get 0 and then minus 1. You would be back to -1. So that's here. So our graph for 2 sine 2x minus 1 for 0 to pi over 2 would look something like this. Okay, yeah, it'll look something like this. So label it y equals 2 sine 2x minus 1. Okay, now let's draw y equals to cotangent 2x. So y equals to cotangent 2x, that's the same as 1 over tangent 2x. Okay, so 1 over tangent 2 times 0, you get a math error. So for x equals to 0, the graph for cotangent 2x is the asymptote. So there's like no value. So it either goes like this or like this. Okay, so now let's do for pi over 4. Okay, it's also a math error. So that means at x equals to pi over 4, there's an asymptote. So yeah. Okay, now let's do for x equals to pi over 2, y over tangent 2 times pi over 2. Okay, unfortunately, we also get a math error for that, so this is also an asymptote. Okay, so how do we know how the shape of the graph is? Well, we can select values of x between the asymptotes. So let's select 1 for between 0 and pi over 4. So The values you can select is pi over 6, which is like 30 degrees. So you get square root 3 over 3, which is, okay, pi over 6. That's like somewhere here. Yeah. Yep. Pi, yeah, pi over 6. Yeah, there's somewhere there. Uh, okay. Now try for like angles more than pi over 6. So you get 0.36. Okay, and then for 40 degrees, I actually set my calculator to degree mode. Yeah. So that's what it's giving me in degrees lah. So okay, 0.1. Okay, this one you get 0.17. Okay. Okay, got a math error. Hmm. Okay, let's do from 1 degree all the way. Yeah, so it starts decreasing from 1 degree, then 3 degrees. So just okay. Okay, I think uh for here it actually is 0, because for the graph of tangent x when x equals to pi over 2, we have an asymptote at x equals to pi over 2. So since this is the inverse, the asymptote just becomes the x-intercept. Okay, so I believe the graph looks something like this. Yeah, so this is the graph of y equals to cotangent 2x. Yeah, so as we can see from our sketch, these are the two graphs and there is one point of intersection. So we can conclude by saying since one point of intersection, exactly one root. And yeah, this would be our final answer for the first part. Let's head on to the second part. Okay, so now we need to show by calculation that the root is in this interval of x. Okay, so to show that, what I like to do is to bring the original equation, so cotangent 2x to sine 2x minus 1, and move everything over to one side. So you get cotangent 2x minus 2 sine 2x plus 1 equals to 0. So start with the lower bound. So sub x equals to 0.4. So cotangent 2 times 0.4 minus 2 times sine 2 times 0.4 plus 1. So 1 over tangent 2 times 0.4. 0.4, make sure your calculator is in radian mode, minus 2 sine 2 times 0.4 plus 1, you would get 0.537, which is more than 0 to 3SF. Okay, now you substitute the upper bound, which is x equals to 0.6. You would get cotangent 2 times 0.6 minus 2 sine 2 times 0.6 plus 1, 3.6, 0.6. You would get minus 0.475, which is less than 0 to 3SF. So in here, we can see that from 0.4 to 0.6, the answer becomes from positive to negative. So there's a sign change. So we can conclude that since there's a sign change, root lies in the interval. Yeah, so we can write shown. And yeah, this would be our final answer for this part. Let's head on to the last part. Okay, so the last part just tells us to use the iterative formula, this to calculate the root corrected 2 decimal places, and each iteration should be given to 4 decimal places. Okay, so for the first iteration, I'm going to let x be the midpoint of these two values, so 0.5. And to get your next iteration, set your initial value as the answer and type the iterative formula into the calculator. And in place of x, just type in answer. So 2 times answer minus 1. And press the equals button once to get your first iteration. So for my first iteration, I got 0.4858 to 4dp. And for the next one, press it one more time to get the next one, you'll get 0.4967. And then for the next one, you would get 0.4883. So the moment when you should stop is when the numbers get like the same when you round it off to 2dp. When the last two iterations, when you round off to 2dp, they become the same when you round it off to 2 decimal places. So that's not the case here yet. So I'm going to iterate more. So 0.4947. Yeah, even more. I'm going to continue here. Okay, we get 0.4897 or 8. Yeah, 8. And then here, more time, we get 0.4935. Okay, yeah, so right now it's still like quite big, the difference. Okay, so this is 0.4906. Now it should start getting smaller. Okay, this one, 0.4928. Okay, this is the last one due to space constraints. Okay, we get 0.4912. So yeah, this is to 4dp. And as we can see for the last two iterations, when you round off to 2dp, you get 0.49. So hence, we can conclude that our answer is 0.49 to 2 decimal places. So this would be a final answer for this part as well as the entire question. Let's head on to the next question. Okay, so for this question, we are given the equation of the curve as such. And for the first part, we need to find dy dx for the curve. Okay, so since the equation of this curve is expressed implicitly, we are going to have to do implicit differentiation. So in order to do that, start by differentiating both sides with respect to x. So 2y cubed minus 3x squared y minus x cubed equals to the derivative of 16. And to differentiate the left-hand side, let's just split everything up. So you get d dx 2y cubed minus d dx 3x squared y minus d dx x cubed equals to, so this is a constant, this will just be 0. Okay, so let's start with 2y cubed. So to differentiate this with respect to x, we differentiate it with respect to y first. So d dy times 2y cubed. And according to the chain rule, we also need to multiply dy dx. And as for this one, we are going to have to use the product rule because, as you can see, it's a product of two functions. So let's start off by removing the 3 and just differentiating x squared times y. And this one, very straightforward, it's just 3x squared equals to 0. So this one would just be 2 times 3y squared dy dx minus 3 d dx x squared plus y. So to differentiate this, we'll use the product rule, okay? So we'll keep the first term, so x squared, and differentiate the second term. So to differentiate the y with respect to x, yeah, we use the same technique here. Differentiate with respect to y first. So differentiating with respect to y, you just get 1, and then you multiply dy dx. So this would just be dy over dx. And then you add it with the second term. So you keep the second term, and you differentiate the first term. So differentiating the first term, you just get 2x. Yeah? Okay. And then this is just equal to this. I'm moving this over to the other side. Okay, so now we can start expanding and simplifying everything. So this just be 6y squared dy dx minus 3 times x squared dy over dx plus 2xy equals to 3x squared. Okay, so 6y squared dy over dx minus 3x squared dy dx minus 6xy equals to 3x squared. Okay, so now keep all the terms in dy dx on one side and the remaining terms on the other. So 6y squared dy dx minus 3x squared dy over dx equals to 3x squared plus 6xy. Okay, so factorizing out dy dx, we would get dy dx times 6y squared minus 3x squared. That's equals to 3x squared plus 6xy. So dy dx, just divide it both sides by this, you'll get 3x squared plus 6xy over 6y squared minus 3x squared. Yeah, so it's not in the full form. So what we have to do, since all the coefficients, they are multiples of 3, we'll divide both the numerator and the denominator by 3. We would get x squared plus 2xy over 3y squared minus x squared. Oh, wait, sorry. This is supposed to be 2. Yeah, so if it's in the exact form, yeah, so this would be a final answer. We can write shown. So yeah, let's head on to the next part. Okay, so for the second part, they told us hence. We have to use the answer from the previous part to find the coordinates of the points on the curve at which the normal is parallel to the y-axis. So notice here that instead of saying the tangent is parallel to the y-axis, they said the normal is parallel to the y-axis. So we know that the normal is perpendicular to the tangent. So if the normal is parallel to the y-axis, the tangent has to be parallel to the x-axis. So let's write that down here. Tangent parallel to x-axis. And what does that tell us about the gradient of the point, of the specific point? Yeah, it just means that the gradient is equal to 0. So hence, dy dx at those points will be equal to 0. Okay, so let's take the expression for dy dx. So x squared plus 2xy over 2y squared minus x squared. Is that the exact? Yep, equals to 0. So you can just ignore the denominator. You'll get x squared plus 2xy equals to 0. So first things first, on the left-hand side, you should realize that there's a common factor x, but factor x. So we're going to factor that out. So x times x plus 2y equals to 0. So yeah, we have two solutions. X is equal to 0 and x plus 2y equals to 0. So this would be one of our solutions, and this would be the other one which we have to figure out. So this will be our first equation. Actually, let's make x the subject in this case. So x would be minus 2y, and this would be our first equation. Now, what do we do with this piece of information? Well, we know that x and y, they also satisfy the equation of the curve. So we can copy down the equation of the curve and just substitute this right into here. So let's copy that down. So 2y cubed minus 3x squared y minus 3x squared y minus x cubed equals 16. This is equation 2. So we're going to just substitute 1 into 2. Okay. Substituting 1 into 2, you would get 2y cubed minus 3x squared. In this case, it's minus 2y squared y minus negative 2y cubed goes to 16. So just expand out everything. So minus 3y minus 2y whole thing squared. So minus 2 squared, that's 4 times y squared. And then minus 2y whole thing squared, you get minus 2 cubed, which is minus 8, and then times y cubed. So y cubed equals to 16. And then you get 2y cubed minus 12y cubed plus 8y cubed equals to 16. So add everything up, okay? Get 2 plus 8, you get 10, and then minus 12 plus 10, you get minus 2y cubed equals to 16. And then y cubed, you get minus 8. Okay, so now just take the cube root on both sides. You would get y equals to minus 2. Sorry. Yeah, so this would be our second set of answer. So don't confuse it with this. This is completely separate. So for this, there's a separate x value. So we're going to find that out. So just substitute it back. So x is minus 2y. So minus 2 times minus 2, you would get 4. So this is the first set. Now, to find the second set where x equals 0, we're just going to sub x equals to 0. Sorry, it's lagging again. Okay, so you sub x equals to 0 into 2. You would get 2y cubed minus 3 times 0 squared. So that's just 0 minus 0 equals to 16. So you just get 2y cubed equals to 16. Then you get y cubed equals to 8, and y is equal to 2. So yeah, this is the value of y when x equals to 0. So hence our two sets of coordinates would be first x is 4 and y is negative 2. And then we have x is 0 and y is 2. So 0, 2. So these would be our final two answers for this entire question. Let's head on to the next question. Okay, so for this question, for the first part, we're told to prove this identity. So sine 4x is equals to all this. So to do this question, we have to first decide from which side we have to start. So usually they tell you to pick the more complicated side, but if you do that, it's going to be pretty hard to go back to this singular expression sine 4x. So instead, this time we're going to pick sine 4x and try to reduce everything in terms of sine x and cosine x. So yeah, let's get started. So we'll start with sine 4x. So one thing to note about this is sine 4x is that sine 4x is just 2 times of sine 2x. So you can rewrite sine 4x as sine 2 times 2x. Okay, and then you can use the double angle formula for this. So yeah, it's right here. Yeah, so sine 2a is equals to 2 sine a cosine a. So this would just be 2 sine bracket 2x, so 2 sine 2x cosine 2x. Okay, so as you can see, everything is still not in terms of sine x or cosine x's. So we have to simplify further. So this sine 2x itself, we can simplify it to 2 times 2 sine x cosine x. And for cosine 2x, since there's more, cosines than sines, I am okay. For cosine 2a, let's just use this expression for now, cosine square a minus sine square a. So yeah, this just be cosine. Oh shoot, what's going on? Cosine square x minus sine square x. Okay, so this would just be 4 sine x cosine x times cosine square x minus sine square x. Okay, so now what do we do? So I believe the best way to move ahead from here is to realize that the um the identity has 4 sine x in it already. So we also have 4 sine x in our identity. So this is the only part which we have to simplify. So everything after 4 sine x should only be in terms of cosines. So this one, we're gonna replace it with cosine square. So 4 sine x cos x. So this one is 1 minus cos x. So you will get 2 cosine square x minus 1. And then now you multiply cosine x to this bracket. Keep the 4 sine x. You would get 4 sine x, 2 cosine cube x minus cosine x. Yeah, so yep, we have proven the identity. So right, proven. If you want, you can also do it from the um right hand side. Okay, as long as you can recognize the double angle formula forms. Yeah, but personally for me, I like to do it this way. So yeah, this would be our answer for this first part. Let's head on to the second part. Oh, okay. This second part is unique. So for the second part, they told us hence. So we obviously need to use the answer. Our identity that we've proven, we need to find the exact value of this trig identity. Okay, so let's try to re-express this into something that we can actually integrate. So let's write our trig identity. Oh God. Okay, so sine for x, sine for x equals to 4 sine x times 2 cosine cube x minus cos x. Okay, so let's try to, um, okay, what should we do? All right. I believe the best approach here would be to just directly substitute sine for x into this expression. So cosine cube x sine 4x, that would just be cosine cube x times 4 sine x times 2 cosine cube x minus cosine x. So you have okay, let's just multiply all the cosine cubes first. So you have 4 sine x. Just like leave the 4 sine x alone again. So you get 2 cosine to the power of 6x minus cosine x to the power of 4x. Okay, so all right. Okay, now let's just leave the sine x alone. So multiply the 4. So you get sine x bracket 8 cosine to the power of 6x minus 4, sorry, 4 uh, cosine x to the power of 4. Okay, so we have re-expressed this. Now we're gonna substitute it into our integral. Okay, so why did I choose to re-express the expression inside the integral in this way? Because we are going to be doing integration by substitution, where if we let u equals to cosine x, then our, okay, so if we let u equals to cosine x, our du dx would therefore be negative sine x. And if we make sine x dx the subject, we would get minus du equals to sine x dx. Yeah, so that's why we're making in this format. So whenever you have like a complicated, trigonometry uh integral, just make it in terms of sines and cosines. Make sure only the sines are in terms of powers, or only the cosines are in powers, and the other one has to be without any powers. So sine x or just cosine x. Okay? Yeah. All right. So since this is a definite integral, we also need to re-express our limits as well. So the upper limit would be cosine pi over 4. Cosine pi over 4, that is just square root 2 over 2. And lower limit is just cosine 0, which is equals to 1. And cosine pi over 4, square root 2 over 2. Yeah, so this is our expression. Okay, now we are going to rewrite our integral. So upper limit is square root 2 over 2, and lower limit is 1. Uh, yeah, so this is, uh, oh wait, what? Okay, it's lagging again. Please give me a while. Okay, so this is 8 u, oh my, what's going on? U to the power of 6 minus 4 times u to the power of 4 sine x dx, that is minus du. So the minus sign, just put it in here. Okay, so if you realize square root 2 divided by 2 is actually smaller than 1, So if you put the negative sign, to get rid of the negative sign, you can just swap the limits. Okay, then you will get 1 square root 2 over uh sorry 2, and then you would just get this integral. So if you have a negative sign on the outside and you want to get rid of it, for definite integrals, you can just swap the upper and lower limits. Yeah, so this would be our final integral. Now we're ready to evaluate it. So 8 times u to the power of 6, that is just 8 times u to the power of 7 over 7 minus 4 times u to the power of 5 over 5, 1 square root 2 over 2. Then you get, just substitute 1. So 8 over 7. Oh gosh, what's going on? I'm sorry, it's lagging a lot. 8 over 7 minus 4 over 5 minus square root 2 over 2. You would get 8 times square root 2 over 2 to the power of 7 over 7. Oh my God. What do we do? 4 square root 2 over 2 to the power of 7. I'm just going to do like a side working here. Is the same as this to the power of 6 times this. So square root 2 over 2 to the power of 6. That's 1 over 8. So 1 over 8 times square root 2 over 2. You get square root 2 over 16. And then for square root 2 over 2 to the power of 5, you get square root 2 over 2 to the power of 4 times square root 2 over 2. Square root 2 divided by 2, you get to the power of 4, 1 over 4 times square root 2 over 2. You would get square root 2 over 8. Okay, all right. So 8 times u to the power of 7. So square root 2 over 16 times 7 minus 4 u to the power of 5 square root 2. Oh my, square root 2 over 8 times 5. So this one would just be 8 over 7, 8. Yeah, they told us to find the exact value, unfortunately. So we're gonna have to factor out a lot of things. Okay, so this first part is just 12 over 35. And then this one is square root 2, bracket 8 over 16 times 7 minus 4 over 8 times 5. You get negative 1 over 35. And then you would get 12 over 35 plus square root 2 over 35. Or if you want, you can express as 1 over 35 times square root 2 plus 2. So yeah, this would be our final answer for this part as well as the entire question. Let's head on to the next question. Okay, so for this question, we are told to let fx be equals to this, where a is a positive constant And for the first part, we are told to express fx in partial fractions. So before we, split up the denominator into fractions, we should check whether the um, degree of the numerator is less than or equal to or more than that of the denominator. So in this case, if you realize the degree of the numerator is 2, as well as the denominator. So since they're equal, we have to do long division first. So let's do that. So let's expand out the denominator. So this would be x squared plus 2ax plus 3ax, that's 5ax, plus 6a squared. Okay, and then now we just do x squared plus 4ax plus 6ax, x squared divided by x squared plus 4ax plus 6a squared. So you just minus this divisor exactly as it is. Since we didn't multiply anything, just write 1. So x squared plus, wait, oh wait, this 5ax. Yeah, so 5ax plus 6a squared. Our denominator would just be 4 minus 5ax. So that's minus ax. So this is our remainder and this is our quotient. So now we can re-express fx as, write down the coefficient, the quotient first, so 1, and then plus the fraction. So in the numerator, you would have your remainder, so minus ax over the divisor. So I'm just gonna write in the factorized form, since we will be doing partial fractions anyway. Yeah, so this is fx. Now we're ready to split this up. So minus ax over x plus 2a times x plus 3a. We can equate this to something over x plus 2a. So since this one is a linear factor, the numerator would be a constant, and then plus x plus 3a over b. Okay, now let's just multiply both sides by the denominator on the left-hand side. So you'll get minus ax equals to a times x plus 2a. This would be gone, like if you multiply. Yeah. So you only have x plus 3a plus b times, you multiply, since this is the denominator, this will cancel out when you multiply x plus 3 with this, so you only have x plus 2a. Okay, so yeah, now we're ready to do it. So first things first, look for any factor that you can equate to 0. So I'm going to start with this. So to make this equals to 0, we have to make x equals to negative 2a. So we'll just sub x equals to negative 2a. Then we'll get a times minus 2a plus 3a. You would get a times a. And this would just be 0. And this will be equal to minus a times negative 2a. So that's just 2a squared. So you can cancel out the a. Then you would get a is equal to 2a. Okay, so wait a minute. Something ain't right. am not sure if it's supposed to be a whole number. Is it supposed to be like this? Okay, minus 2a, yeah, that's a. Yeah, so a times small a equals to minus a times negative 2a. So that's just 2a squared. Yeah, so you get a equals to 2a. Okay, I don't think anything's wrong. Yeah. All right. So that's for A. Now to get B, we're gonna have to make this factor equals to 0. So to make this equals to 0, we need to substitute x equals to negative 3a. Yeah, so this is gone. So now we only have B. So negative 3a plus 2a, that's minus a. So we have B minus a equals to minus a times negative 3a. So that's just 3a squared. So the a's, they cancel out again. And then you would have b is equals to minus 3a. So yeah, hence we can express our fx in terms of 1 plus a over 1 x plus 2a. So a in this case is 2a over x plus 2a plus b over x plus 3a. So b is minus 3a. So minus 3a over x plus 3a. So yeah, this would be our final answer for this first part. So let's head on to the next part. Okay, so for this part B, we told hence. So we have to use the answer from the previous problem to find the exact value of this integral of fx from a to minus a. We're told to give our answer in this form where p and q are rational. Okay, so let's write down the integral. So we have 1 plus 2a over x plus 2a minus 3a over x plus 3a dx. Okay, so let's start. So to integrate this, let's first integrate the 1. So integrating 1 with respect to x, you get x, and then plus integrating this. To do this, you have to make it in the form of f prime x over fx. And it's possible since the denominator of the numerator is 1 less than the degree of the denominator. So you can only make it f prime x over fx if that's the case. So you have a constant over linear or a linear term over quadratic. Yeah, then you can make in this form. So making this form, we get, for this, you get 1 over x plus 2a, f prime x over fx, and to, not change this, you can take out the 2 over a. Yeah, so this would integrate, you'll get 2a ln x plus 2a. And then minus this, same thing. It's also integral of 1 over x plus 3a. And to make this same value, just keep the 3a outside. Then you get minus 3a times ln x plus 3a. Yeah. Okay. So yeah, now we need to substitute our limits. So let's substitute a first. So we get a plus 2a ln a plus 2a, you get 3a, then minus 3a ln a plus 3a, that's 4a, and then minus bracket, now you substitute negative a, so you get negative a plus 2a ln negative a plus 2a, you get a minus 3a ln negative a plus 3a, you get 2a. So expanding and simplifying, you get a plus 2a ln 3a minus 3a ln 4a plus a minus 2a ln a plus 3a ln 2a. So a plus a, you get 2a, and then 2a ln 3a minus 2a ln a, you get 2a ln 3a. Yeah, I'm just going to group all the terms first. And then this one, just swap the terms. So you get plus 3a ln 2a minus 3a ln 4a. So 2a plus 2a times ln 3a minus ln a plus 3a times ln 2a minus ln 4a. Okay, so to simplify the bracketed expressions, since they have the same base, the logarithms, and different numbers, we can use this log law. So log a minus log b is supposed to get log a over b. Yeah, so you can just rewrite as ln 3 over a. So basically just ln 3. And let's do the same for ln 2a minus ln 4a. So you are supposed to get ln 2 over a over 4 over a, which is ln 1 over 2. Okay. All right. Let's try to um, add up the logarithms first. All right, so this ln half, we can re-express it. So ln half, we can write it as ln 2 to the power of negative 1, and using our rule, we can bring this power down to the front. So it'll be 3 times a times negative ln 2. So this would be 2a plus 2a ln 3 minus 3a ln 2. Okay, let's factor out the a. So you get 2 plus 2 ln 3 minus 3 ln 2. Okay. And now to simplify the lns, the logs, we're going to take back the coefficients and make them as powers using our power rule. So this 2 will go up here, and it'll become ln 3 to the power of 2, ln 3 squared, just ln 9 minus, do the same for this, you get ln 2 cubed, so ln 8. And then you get a times 2 plus ln 9 over 8. Okay, so, all right, I believe we're correct. Okay, so, yeah, I believe this counts. So, yeah, this would be our final answer for this part, as well as the entire question. Yeah, it fits the form. Let's head on to the next question. Okay, so for this question, we're shown a diagram which shows a tank for holding water. So this is a tank. The tank is in the shape of a cube of sine 50 cm. So it's a cube at time t seconds. The depth of water in the tank is H centimeters. And we're told the water is poured into the tank at a rate of 500 centimeters cubed per second. And at the same time, water pours out of the tank through a hole in the bottom at a rate proportional to H square. Okay, I get it. So yeah, when H is equals to 20, so this is the initial condition, the depth of the water increases at a rate of 0.4 cm per second. Okay, so for the first part, we need to show that this differential equation is valid. Okay, so let's start. Okay, so let's try to relate volume. Let's make an equation for the volume. So volume here, like the total volume, is just 50 times 50 times H. So volume is just 2500 H. Okay. And let's do dVdH. So this is going back to your connected rates of change from AS. Okay, so we know that dV dt, the rate of change of volume, it's equals to 5,000 minus the water pouring out. So that one is proportional to H squared. So I'm gonna just let it be K H squared. Okay. All right. Okay. So let's make an equation for dV dt. So to do that, use your chain rule. So dV over something times something, oh my God, over dt. So this something would obviously just be dH. So dV dt, that's 5,000 minus kh squared. And dV dH, it's 2,500. And dH dt, don't know what that is. So to get our final answer, we're going to use this initial condition for H. So when H is 20, the depth of water is increasing at a rate of this. So the depth is H. So dH dt is 0.4. So 5,000 minus K times 20 square equals to 2,500 times 0.04. Okay, so 20 square, that is 400. So 400K equals to 5,000 minus 2,500, and 0.4 is 1,000. And then K, you would get 10. Yeah. So hence we got 5,000 minus 10 H squared over equals to 2,500 dH dt, and making dH dt the subject, you get 5,000 minus 10 H squared over 2,500. Yeah, just divide everything by 10. You would get the final answer. dH dt equals to 500 minus H squared over 250. Yeah, so we can write shown So this would be our final answer for the first part. Let's head on to the next part. Okay, so now they give us more initial conditions that h equals to 0 when t equals to 0. We need to find the time taken for the depth of the water in the tank to reach 20 centimeters square. So to do that, we need to first solve the differential equation we found in part A. So dH dt equals to 500 minus h squared over 250. So first step is to separate the variables so that all the h terms go to the left-hand side. So 1 over 500 minus h squared dh, and then 1 over 250 dt. Okay, so now we can start integrating it. To integrate this one, let's we need to let's just make it into the form of, so let's for to MF19 go to integration. So our equation, we have to make it into this form, a squared minus x squared, the denominator. So this is going to be 1 over square root 500. That is 10 square root 5 square minus h square dh. And then this one is 1 over 250 t plus c. And to integrate this, 1 over a squared minus x squared, you get 1 over 2a ln a plus x over a minus x. So you get 1 over 2a ln a plus x, which is 10 square root 5 plus h over a minus x, 10 square root 5 minus h. You could have, chosen to just express this in partial fractions, but I don't really have the time to do that. So make use of the formula list. Okay. Okay, so now we're going to find our unknown constant c using these initial conditions. So we'll substitute h equals to 0 and t equals to 0. So substituting that, you will get c equals to 1 over 20 square root 5 ln 10 square root 5 plus 0 over 10 square root 5 minus 0. Then you would just get 1 over 20 square root 5 ln 1, which is 0. Yeah, so we can just express this as 1 over 20 square root 5 ln 10 square root 5 plus h over 10 square root 5 minus h equals to 1 over 250 t. Okay, so in this question, they told us to find the time taken for depth to reach 20 centimeters. Okay, so we have to make t the subjective here. Luckily for us, very simple. Just multiply both sides by 250. Then you would get 250 over 20, which is 25 over 2 squared 5 ln 10 squared 5 plus h over 10 squared 5 minus h. So this is the expression for time. Now we'll just substitute h equals to 20. So t will just be 25 over 2 squared 5 ln 10 square root 5 plus 20 over 10 square 5 minus 20. Okay, so 10 square root 5 plus 20 over 10 square root 5 minus 20. Okay, that's a positive answer. Okay, so 25 over 2 square root 5 ln of that, you would get 16.1 seconds. Yeah, seconds to 3SF. So this would be our final answer for this part as was the entire question. And as for how to know which is the correct units, you have to go back to the main part of the question where they specified what's units they use. So in this case, it's cm, cm cube, and seconds. So yeah. So with that, let's head on to the last question. Okay, so for this question, we're given this diagram, and relative to the origin O, we are given the position vectors of point A, B, and C, which are respectively these. And we're also told that the midpoint of AB is M, as shown in the diagram. So yeah, this is the midpoint M. And for the first part, we're told to find the vectors MB and MC. Okay, so to find that, we have to realize that MB is actually collinear with AB. Like MB is literally just half of AB. Same can be said for, wait, MC. Okay, so let's just find MB first. So MB, that's just half of AB as we established. So AB is just OB minus OA. Mhm. So you get half of OB. So OB is just 284. And then OA is 4 minus 2, 0. And then this half 2 minus 4, that is minus 2. 8 minus negative 2, that is 10. And 4 minus 0, that is 4. So half of that you would get negative 1, 5, 2. So this is MB. And now we're going to find MC. Okay. Sorry. Okay, so this is MC. So to find it, yeah, we can see that MC, yeah, using a triangle law, it's just MB plus BC. So MB is negative 152, and BC is OC minus OB. Okay, and then minus 152 plus OC. OC is minus 2I. There's no J, so that's 0, and then 6K. And then minus OB is 2I and 8J, and then 4K. So adding all this up, you get minus 1, minus 2, that's minus 3, minus 3, minus 2, which is minus 5, and then 5 plus 0, that's 5, 5 minus 8, that is minus 3. And 2 plus 6, that's 8. And 8 minus 4, that is 4. Yeah, so this would be our final two answers for the first part. So all these, let's head on to the next part. Okay, so for the second part, we are told to calculate the exact value of the cosine of angle CMB. Okay, so to do that, let's take a look at our diagram again. So this is angle CMB, and to calculate angle CMB, we can use our, what you call, the scalar product. So the formula for that is given here. So A dot B is equal to the magnitudes of A times magnitude of B times cosine theta, where theta is the angle between the two vectors. So in this case, the vectors that we're concerned with for the angle CMB is just MC and MB. So yeah, this is just going to be MB dotted with MC equals to the magnitude of MB times the magnitude of MC cosine of the angle CMB. So MB is -152 dotted with -5, -3, and 4. And then the magnitude of MB is -1 squared, that's 1, plus 5 squared, which is 25, plus 2 squared, which is 4, and then times the magnitude of MC, which is -5 squared, which is 25, plus -3 squared, which is 9, plus 4 squared, which is 16, cosine CMB. So let's simplify everything. So -1 times -5, that's 5, plus 5 times -3, that is -15, plus 2 times 4, that's 8. So you get -2. And then square root 1 plus 24 plus 25 plus 24 is square root 30 times square root of 25 plus 9 plus 16. You get 10 square root 15 cosine CMB. Yeah, okay. All right. So cosine CMB, according to this, is -2 over 10 squared 15. So this is 1, this is 5. You would just get -1 over 5 square root 15. So yeah, this would be a final answer for this part B. Let's head on to the next part. Okay, so for the final part, we need to hence or otherwise, so you can either use your answer from the previous part or use the other way to find the exact area of triangle ABC. Okay, so let's refer back to our diagram. Let's try to copy it down. So triangle ABC is this entire triangle here. So let's copy it down scale to scale. Yeah, so wait a minute. This is this point A and this point B. Oh wait, sorry, that's point C. Okay, that's point C, and then this is point B. Wait, only. Oh, okay. All right, and we got the midpoint of M in here. So that is CMB. and we know the cosine of this angle in here. Okay, yeah, so to find the area of triangle ABC using the information that we have so far. So far we know the cosine of angle CMB. We can, so ABC, the area would just be the area of CMB plus the area of this other triangle called CMA. Okay, all right. So to find the area of CMB, since we know this angle right here, we're going to use the formula half AB sine C, where A and B are two sides, and C is the angle between A and B. So since we only know C and B, so we have to let these two sides be A and B, basically. Okay, so yeah, we know our magnitude of MC and MB. So just half AB. So A is wait, AB, we already know. It's just this 10 squared 15, right? So yeah, it's just 10 square root 15. Sine CMB, right? And yeah, just sine CMB basically. And then plus for CMA, since we know this side and this side is also B because M is the midpoint, cutting it in half. This would just be, so since we know these two sides only, we need to know this angle CMA. So half times AB, so 10 squared 15, again, times the sine of angle CMA. So this sine of angle CMA, so angle CMA is just 180 degrees minus CMB. Yeah, so to determine our trig stuff, so for sine CMB, we can use like our trig identity. Yeah, our very fundamental trig identity, cos squared theta plus sine squared theta equals to 1. So rearranging, you'll get a square root of 1 minus cosine square CMB. So you'll get 1 minus square this, you'll get minus 1 over 5 squared 15 square, you'll get 1 minus 1 over 375, and you'll get square root 374 over 375. Yeah, so that's sine CMB. And as for sine 180 minus CMB, or just sine CMA, you can use the subtraction formula. So sine A minus B, that's sine A cos B minus cos A sine B. So this is going to be sine 180 cos CMB minus cos 180 sine CMB. So sine 180, wait, sorry. Sine 180, that is 0. So this is completely gone. And then cos 180, I believe should be -1 here. So minus -1, that's just plus 1. So just equals to sine CMB, okay? Which is square root 374 over 375. Yeah, so now we can find ABC. So it's just half times 10 square root 15 sine CMB, square root 374 over 375 plus half 10 square root 15 square root 374 over 375. So simplifying all this, 10 square root 15 times 374 over 375. Uh, so 374 times 15, you would get 5610. 5610 over 375. Yeah. And 5610 over divided by 375. That gives us 10 square root 374 over 25. And then we can use a log indices to split the square root. So 3 square root 374 over square root 25. Square root 25 is just 5, so 10 divided by 5, you get 2. So this is just 2 times square root 374. So this would be our final answer for this part, as well as the entire question. And we have also come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel for more future videos regarding A-level maths and further maths. If you guys have any feedback or any questions or any future video ideas, please feel free to leave them down in the comments below. And yeah, I'll see you again next time. Okay, thank you.